welcome back. This is Rakesh Naik. Today we are going to discuss about circular queue. We'll see how to implement a circular queue using array. In my previous video, we have discussed how to implement a queue using array as well as using linked list. So before we start, a small information I'd like to share. In this channel, we produce every video in two different languages, Hindi as well as in English. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. We have already discussed about what is a queue, how to implement it using a linked list as well as using an array. If you have not seen all those videos, I'm giving the link above in the I button. Kindly watch it. In today's session, we are going to discuss how to implement a circular queue using array. So let us see. In our day-to-day life, everywhere we are experiencing a queue. We know it. But in computer science, a printer spooler implements a queue using which the printer takes the command from printer spooler and prints accordingly. It means in the printer spooler, whichever data or whichever command is on the front, that particular command will be getting printed first. So what is the definition of a queue? A queue is defined as a restricted list where all the insertions are done at one end, that is called a rear end, and all the deletions are done at the other end, that is called a front end. But what are the basic limitations that we get from a linear queue? This definition what we discussed is a definition of a linear queue. So the basic limitation is suitable code need to be written in order to make the front regularly catch up with the rear and reset both. Array implementation of linear queue leads to queue full state even though the queue is not actually full. This is the very important thing. To understand this, let us see a small graphics from which you will be able to understand. Now let us say front and rear are pointing to -1. Nothing is there in the queue. So one data came. So rear is increased by 1. Another data came. Rear is still increased by 1. Another data came. Rear we are incrementing and adding the value at the rear. Let us try to add few more data. So 4 we got added, 5 we got added, and let us say 6 also we are adding. So there are 0 to 5. In these locations 1 to 6 data are inserted. Now let us say I want to insert any more data. Is it possible? No, because the rear is already pointing on the last of the array. So there is no way we can add any more element to this particular linear queue. Let us try to delete few elements. While deleting, we know that we need to increment the front and we'll be deleting the element pointed by the front. So now imagine 2 elements got deleted. There are some vacant spaces in the front, but as the rear is pointing to the last one, we cannot insert any more into the queue. Even though there are vacant spaces in this queue, but still we are not allowed to enter any more data into the queue. So the queue is not actually empty. As the rear is pointing to the last element, we cannot make any addition to the queue. In order to make addition to the queue, existing queue, we need to readjust the front. In order to add any more element to it, we need to shift the element which are there in the front to the very front. It means we need to make vacant places at the rear. So we need to shift the elements 1 or 2 spaces that will indicating the front. Now rear we are having some empty spaces. Now we can enter any more data at this particular location. So in order to overcome the limitations of the linear queue that we have seen right now, we will be implementing a circular queue. So let us see how to implement a circular queue and what actually it is with the help of example. Let us see what are the advantages of circular queue. Now by using a circular queue, data shifting is avoided as the front and rear element are modified by using a mod function. The mod operation wrap up the queue back to the beginning. And the second advantage of circular queue is if the number of elements to be stored in a queue is fixed, the queue is advantageous because we need not shift the elements which are being deleted and which are existing right now. And the third advantage, we are having many practical applications such as printer queue, priority queue, and simulation uses the circular queue. Whatever operation we perform with the linear queue, the same operation we can perform with circular queue also. Let us see what are they. First operation is add. We are adding an element to the existing queue and always will add at the rear. Delete from the queue. So always will be deleting from the front of the queue. Next operation that we perform is get front. So whatever is there in the front of the queue will just receive the data, will just retrieve the data. We are not going to delete. And in order to implement, we need two more functions. One is called isEmpty. Every time we want to delete it, isEmpty is checked in order to say whether the queue is empty or not. And the next operation is isFull. So every time we want to add an element, isFull must be checked. It need not exceed the limit of the queue size. We know that we can implement a queue using array as well as an linked list. So in this video, we are going to say how to implement a circular queue using array. And if you feel knowing the representation of a circular queue using array and linked list are important, then give a thumbs up and share among your friends. For better understanding, please watch this video till the end. We are defining a class called CQ, that is circular queue, and two items we are taking. One is CQ item, we are giving a size, an array, and we are representing front and rear to be -1. And these are the functions that we are going to implement. Let us see how insertion and deletion can be done in a circular queue with the help of the small graphics. Let us say these are my data already available. Front is pointing to 0th index and rear is pointing to the 7th index. If I want to delete an item, I'll delete from the front. I'll increment the front by 1. Now front will be pointing to the first location, that is data item 2. If I want to delete any more data, again the item 2 will be deleted, which is pointed by front. Again I'll be incrementing the front to the next one. If I want to add a item, then I'll add the item at the next vacant place, that is at 0th location. Now whatever we are discussing, the conditions for queue full, that is very, very important. Queue empty, while queue is empty, front and rear supposed to point to -1. And when queue is full, how to check the condition, this is very, very important. So if you understood this point, implementation of circular queue using array will be very, very easy. Just keep concentrating. The first condition is front equal to 0 and rear equal to size -1. Let us say here front is pointing to the 0th index and rear is pointing to the size -1, that is 7th index. So this is one condition where I can say the queue is full. Now the second condition is front equal to rear +1. Let us see how. Now let us say we have deleted this item. Front is now pointing to this item. Again we have deleted 2. Now front is pointing to the 2nd index. Now let us say I want to add an element. So what I have to do? I have to increment the rear, and rear now will be pointing to 0th and 0th index. I want to add the data 9. Let us say one more data I want to add. So rear I have to increment, and after rear's increment at the first location, element 10 is now added. Now you can see front is pointing to the 2nd index while rear is pointing to the 1st index. Now also the queue is full, but in order to check this, we can have this front equal to rear +1. Rear is now pointing to 1, front is now pointing to 2. So this condition is holding. So if you understood these two conditions, your Q full condition checking will be very, very easy and implementation will be very, very easy. Now let us try to see how to insert an element in a circular queue using array. Now imagine that there is a circular queue and I can add only 4 elements to it. Now front and rear is pointing to -1. Now we are having a function CQ add and we are passing a parameter called element, which is an integer data type. Now let us see. If is full. Now if this condition is true, we need to write the queue is full. But this condition is false. That's why we'll come to the else part. In the else part, we are having if front equal to -1. Yes, front equal to -1, it is true. Then in that case, we'll write front equal to 0. So front we will be pointing to 0 and rear equal to rear plus 1 mod size. Rear is now pointing to -1 and after the execution, rear will be pointing to 0th index. So now rear is pointing to 0th index and at the 0th item, now at the 0th index, we are passing the element and it will be saved. So if 1 is the element that is being passed, 1 will be placed at 0th index. In order to understand, for a linear queue at a 0th index, 1 is placed. Now let us add one more element. This queue full condition is false. That's why we came to else part. And here, if condition front is equal to -1 is false. So we'll directly come to the next, that is rear. So rear equal to rear plus 1 mod size. So rear is now pointing to 0. So after the execution, 0 plus 1 mod 4 becomes 1. So at 1th location, we are going to add our element. So at CQ item rear is 1. At 1th location, we are placing the element. So the second 2 we are adding at 1th location. Similarly, in order to view in the form of a linear queue, at the first index 2 is placed. Now let us see, add one more data. This queue full condition is again false. We are coming to else part. This front equal to -1, this condition is also false. So next step is rear equal to rear plus 1. Now rear is pointing to 1. So 1 plus 1 mod 4, that is 2. So on the second index, we will be placing our element. Let us say 3 is the element I want to place. I want to place at the second index. So in order to watch this linear queue point of view, on the second index, element 3 is added. Now let us add one more element. Rear equal to rear plus 1 mod size. 2 plus 1 mod 4 is 3. It means at third index, we are going to add our element. So CQ item 3 is element. So element 4 is placed at the third location. So in order to realize in the form of a linear queue, so in the third index, element 4 is placed. Now let us see how can I check my queue full condition. When I am coming to is full, this condition will be checked. So if front equal to rear plus 1 or front equal to 0 and rear equal to size -1. So here you can see the front equal to 0 and rear equal to size -1. This condition is true. So it will return 1 and I'll come out of this particular if condition. So I cannot add any more element to this circular queue. Now let us see one more condition here. Now assume that front is pointing to 1 and rear is pointing to 3. Now if this is full condition, if you are checking, so one more vacant place is there. So that's why we'll come to the else part. Front equal to 1, this condition is also false. So again we'll come rear equal to rear plus 1 mod size. So now rear is pointing to 3. So 3 plus 1 mod 4, the value is 0. So at the 0th index, I'll place my item. Next element is, let us assume 5. 5 is placed at 0th index. Now possibly you understood how this mod function is working, how the mod function is working in a circular queue. Now you can see at the 0th index, element 5 is placed. Now let us check again for queue full condition. Now rear is pointing to 0 and front is pointing to 1. When we are checking is full, what will happen? Is full condition we are going to check. Here front equal to rear plus 1. This condition will be true. So front is equal to 1, rear equal to 0. So 0 plus 1 is equal to 1. This part is true. So that's why it will return 1. So it will print Q full and it will come out of the if condition. I hope you understood how to insert a data in a circular queue using array. Now let us see how to delete a element from a circular queue. There is no parameter need to be passed and we are taking an element that is integer data type and we are taking a condition if empty. If it is empty, we will be writing Q is empty and we will return -1. Otherwise, we will look into this set of code. Now let us say we are starting with this. Is empty condition is false because the queue is not empty. So that's why we'll come to the else part. In the else part, what we have to do? Whatever is there in the front, we'll save it in the variable called element. So in the element, 0th item is placed. So element contains data 1. Now if front equal to rear, front is not equal to rear. So that's why again we'll come to the else part. So front equal to front plus 1 mod size. Now front is 0, 0 plus 1 mod 4 equal to 1. So now front will be pointing to 1. So the 0th data in the 0th element is now got deleted. Now we'll say element is deleted and we'll return the variable called element. Let us delete one more data from here. So here again if empty condition, this condition is false, that's why we'll come to the else part. Front's index is 1. So 1th, so CQ's first index element will place it in the variable called element. So CQ's first element we are placing in element and the element value is 2. So if front equal to rear, front is not equal to rear, that's why we'll come to the else part. Front equal to front plus 1 mod size. Now 1 plus 1 mod 4 equal to 2. So now front will be relocated at index 2 and we'll say the element is deleted and we'll return the variable called element. Now let us delete one more element. Now again if empty condition is false, that's why we'll come to the else part. And in the else part, the front element is pointed by index 2. And this, the value in this particular index will be saved in the variable called element. Now after the execution, second index item is kept in the variable called element, that is the data 3. Now again front equal to rear. Is this condition true? No, this condition is not true. Again we'll come to the else part. Front equal to front plus 1 mod 4. After the execution, we'll get 2 plus 1 mod 4, that is 3. So front will be pointing to the index 3. We'll write element is deleted and we'll return the variable called element. Now in the queue there is only one element. Let us try to delete it. Again we are checking is empty, is it true? No, it is false. So again we'll come to else part. In the else part, queue's front equal to element. So the front element is pointed by the third index element and it is saved in the variable called element, that is element 4. Now if condition is true, rear equal to front. So front equal to -1 and rear equal to -1. Front and rear is placed by -1. And again we'll come to the else part and we'll write the element is deleted and we'll return the value. Again if I want to check is empty, again is empty function I'll call. Front equal to -1. If front equal to -1, it is true. Yes, front is pointing to -1. So I'll return 1. So it means the condition is true. So I'll write Q is empty and I'll return -1 to indicate that there is no element in this particular queue to delete. I hope you understood how to delete an element from a circular queue when the circular queue is implemented through an array. Let us see one more function, that is get front function. It is also very easy. Now we are taking a variable called element which is integer data type and we are checking is empty. If this condition is true, it will return -1 saying that the queue is empty. Otherwise it will come to the else part, and the else part you will save the front data in the variable called element. So front is now pointed by the index 1 and it is saved, and the element variable is saving the data, that is data 2, and we will be returning the data element 2. Remember it, we are not deleting the element, we are just taking a copy of it and printing it. Let us see the program segment. Already we have seen this set of codes. For adding, we are doing this set of work. We are checking the condition is full. If is full is true, we are saying that we cannot enter any more data, queue is full. Otherwise we are coming to the else part. If front equal to -1, we are assigning front back to 0. Otherwise, even though this condition is not true, we are saying rear equal to rear plus 1 mod size, and at the rearth index we are adding the element, we are passing the element to it. And in order to check the queue full condition, we have already seen front equal to rear plus 1 or front equal to 0 and rear size -1. Under this condition only it will return 1 to indicate the queue is full, otherwise the queue is empty. Here you can see how to delete it. We are checking if empty condition. If empty condition is true, we are saying the queue is empty. Otherwise, we are saving the element which is given by the index front, and we are saving it in the element. If front is equal to rear, we are saying that front and rear equal to 0 in order to say after the deletion the queue will become empty. Otherwise, we are saying front equal to front plus 1 mod size. We are giving a print statement, the element is deleted, and returning the element. And in order to check is empty, we are saying if front equal to -1, we'll return 1 in order to indicate the queue is empty, otherwise we'll return 0. I hope you understood the total process, how that we can do the operation addition, deletion and get front from a circular queue when it is implemented using array. If you understood the video, kindly give thumbs up and share among your friends. In our next video, we are going to discuss about how to implement a circular queue using linked list. So see you then. Take care. Bye.